This LOS is identify the appropriate test statistic and interpret the results for a hypothesis test concerning the mean difference of two normally distributed populations. The t-test for tests concerning mean differences is based on data arranged in paired observations, and the test itself is sometimes called a paired comparisons test. Paired observations are observations that are dependent because they have something in common. A paired comparisons test is a statistical test for differences in dependent items. So once again on this slide I'm showing the different test statistics, and I've highlighted in green bold the mean differences test. Okay, so again as I've said, the key is to read each question carefully, identify which test is being done, use the right formula to get the test statistic, compare the test statistic versus the level of significance, and then accept or reject. Tests concerning mean differences. So we're going to let the mu d stand for the population mean difference. We can formulate the following hypothesis where mu d0 is a hypothesized value for the population mean difference. Now again, in practice, the most commonly used value for the mu d0 is 0. So in our numerator then, what we're going to be looking at is the mu d, which is the population mean difference. Okay, so the three hypothesis is that it equals 0 or doesn't equal 0, greater than 0 hypothesis, or a less than 0 hypothesis. So again, we have to identify which test is being done, know how to calculate the test statistic. So in this case, the numerator is going to be the mean difference minus 0 divided by the standard error of the estimate in the denominator. We remember that the standard error of the estimate is the standard deviation divided by the square root of n. So again, we're going to improve our understanding of this LOS by working through a practice problem. So using the sample results given below, drawn as 25 paired observations, so there's the word paired observations, from their underlying distributions, test if the mean returns of the two portfolios differ from each other at the 1% level of statistical significance. Assume the underlying distributions of returns for each portfolio are normal and that their population variances are not known. So for portfolio 1, we have a mean return of 17 and a standard deviation of 15.5. For portfolio number 2, we have a mean return of 21.25 and a standard deviation of 15.75. So we can see the difference between the mean returns is 4.25, and the difference between the standard deviations is 6.25. So it says 25 paired observations, that's our n, and the t statistic for 24 degrees of freedom, n minus 1, at the 1% level of statistical significance equals the 2.807. So in this case, they've given you the critical value. So then, based on the paired comparisons test of the two portfolios, the most appropriate conclusion is A, reject the hypothesis that the mean difference equals zeros, as the computed test statistic exceeds 2.807, accept the hypothesis that the mean difference equals 0, as the computed test statistic exceeds 2.807, or C, accept the hypothesis that the mean difference equals zeros, as the computed test statistic is less than 2.807. Okay, we'll work through this solution again fairly slowly, make sure that we understand it. So the first thing, as I said, is always read the question very carefully to identify which test is being done so that you know which test statistic that you need to use. So here I've put in green boxes a couple of the key words here. You can see that reject the hypothesis that the mean differences. So if it's a mean difference test, this is the test statistic that you have to calculate. So you can see the mean difference equals 0. You can also see up here, I didn't put in a green box, but it's talking about drawn as 25 paired observations. So as we said, the mean difference test is also called paired observations, or sometimes called a paired comparisons test. So that was the second piece of information to lead you to the conclusion that this is the appropriate test statistic that you need to calculate. The second thing is that you can see that we can make the mu d0 equal 0. So in the numerator, we've got the second part of the numerator is going to equal 0. So we know that it's just the numerator is going to be the difference, which is the 4.25. The difference in the means. Okay, so I put that in a green box as well. That's the numerator, the difference in the means minus 0. So it's 4.25 minus 0, and then it's just going to be divided by the standard error of the estimate, which we know is the standard deviation, which they've given to us here, divided by n, and n equals 25 because there's 25 paired observations. So this question is not too difficult. It's they've given you 4.25, the difference, minus 0, divided by 6.25 divided by the square root of 25. So we're going to calculate 3.4. As 3.4 is greater than the critical value, we can reject the null hypothesis that the difference is 0. And so therefore the correct answer is A. We're going to reject the hypothesis that the mean difference equals 0, as the computed test statistic indeed does exceed 2.807. So that one's not too bad. And that's the last slide that I have for this LOS. Thank you.